Namaskar, welcome to Exercise Explained. In this video, I would be doing exercise 4B, Pressure in Fluids and Atmospheric Pressure, ICSE 9th, Physics. So, I would be doing question number 1 and question number 2 in this particular video. Hope you guys like the video. Do share it with your friends and consider subscribing to the channel. Starting with the first question, convert 1 millimeter of mercury. So the height is given as 1 millimeter into Pascal. Take density of mercury as 13.6 into 10 to the power of 3 kg per meter cube, and acceleration due to gravity is supposed to be taken as 9.8 meter per second square. So for doing this, I would write the given data. So I wrote H. So H is equal to 1 millimeters. Density, that is rho, is equal to 13.6 into 10 to the power of 3 kg per meter cube, and acceleration due to gravity is 9.8 meter per second square. Now, as we can see, acceleration due to gravity is there in SI unit, density is there in SI unit, but height is not there in SI unit. Now let us understand how to convert 1 millimeter to meters. So all of us know that 1000 millimeter is equal to 1 meter. So 1 millimeter will be equal to 1 divided by 1000 meter. So 1 millimeter will be equal to, I can write 1 by 1000 as 1 by 10 to the power of 3 meter. Now 10 to the power of 3, when it comes to the numerator, it becomes 1 millimeter is equal to 10 to the power of minus 3 meter. Now here I can write this as 1 millimeter as 10 to the power of minus 3 meters. So now we have got all of them in SI unit. This is height is also there in SI unit, density is also there in SI unit, and acceleration due to gravity is also there in SI unit. Now I would be using the formula P is equal to P, that is pressure, is equal to H, that is height, into rho, that is density, into acceleration due to gravity. So what I get here is, I would substitute the values. So height happens to be 10 to the power of minus 3 into density happens to be 13.6 into 10 to the power of plus 3 into, here I get it as 9.8 meter per second square for the case of G. So once we multiply this, we can see here 10 to the power of plus 3 and 10 to the power of minus 3 cancels. 13.6 into 9.8 gives us 133 point. So here we get 133.28 pascals. So we have got the pressure in pascals. Coming to the next question, that is, at a given place, a mercury barometer records a pressure of 0.70 meter of mercury. So what is this? This would be the height because it is given in meters. What would be the height of water column? So we need to find the height of water. We need to find the height of water column if mercury barometer is replaced by water. So it is replaced by water. Density of mercury is given as 13.6 into 10 to the power of plus 3 kg per meter cube. So here I will write height of mercury is 0.70 meters. It is already there in SI unit. Density of mercury, so that is rho m, is equal to 13.6 into 10 to the power of plus 3 kg per meter cube. After this, height of water, that is H and W, we need to find out. And here, density of water, we are supposed to remember that is 10 to the power of 3 kg per meter cube. So this is the density of water. G value we can consider anything. I would consider it as 10 ms minus 2. So see pressure. So now I would write pressure in mercury is equal to pressure in water. So I would be using the same formula as I used in the previous question, that is P is equal to H rho G. So we can write H rho G for the case of mercury is equal to H rho G for the case of water. Now we would be substituting the values. So height of mercury is given as 0.70 into density of mercury is 13.6 into 10 to the power of 3 into acceleration due to gravity, we considered it as 10, is equal to height of water we don't know, so I would take it as HW, into density of water would be taken as 10 to the power of 3 into acceleration due to gravity for the case of water will be taken as 10. Now I would be cancelling few things here. 10 and 10 cancels here. After this I can cancel this 10 to the power of plus 3 and 10 to the power of plus 3. So we get HW is equal to 0.70 into 13.6. So we get the value of height of water column as 9.52 meters. So 9.52 meters happens to be the height of the water column. Hope you guys have liked the video. Question number 3 onwards would be there in the next video, the link for which will be provided in the description. Do check that out and share the video with your friends. Dhanyavad.